For the function f of x equals square root of 5x, let's find the equation of the secant line that goes through x equals 0 and x equals 5. And then let's find the equation of the tangent line at x equals 5. The slope of the secant line is the average rate of change. That's the change in y over change in x. So I'm going to plug both 0 and 5 into my function to get my y values. F of 5 becomes square root of 25, or 5, and f of 0 is square root of 0, or 0. So change in y is 5 minus 0. Turns out change in x is also 5 minus 0. So slope of the secant line, or average rate of change, is 1. Then I can use my point slope formula. The slope is 1. I'll use an x value of 0, which goes with the y value of 0. I plug that into my formula, and I'm left with the equation y equals x. If I want to find the equation of a tangent line, well, to find the slope, we're going to have to compute the instantaneous rate of change. That means we're going to find the limit as h goes to 0 of f of 5 plus h minus f of 5 all over h. F of 5 plus h, that means we replace the x with 5 plus h, and I get square root of 25 plus 5h. I can't simplify that expression. F of 5 is root 25, or 5. I plug that into my limit definition. To find this limit, I'm going to rationalize the numerator. I'm going to multiply the top and bottom by the conjugate, which just means change the sign between the square root and the other number. Then to multiply the numerator out, I'm going to use the fact that when you multiply a plus b times a minus b, you get that difference of perfect squares. So in the numerator, we should get square root of 25 plus 5h squared, first term squared, minus 5 squared. I'm just going to copy down the denominator. I never distribute in the denominator. Square root of 25 plus 5h squared is just 25 plus 5h. 5 squared is 25. And so if we combine like terms in the numerator, the 25's go away. Again, I don't do anything to the denominator. Now I can cancel an h out of the top and the bottom, and I'm left with 5 over square root of 25 plus 5h plus 5. Finally, to find this limit, I replace the h with 0, and I'm left with 5 over root 25 plus 5, or 5 over 10, or if I reduce, 1/2. So my slope is 1/2. Now they asked for the equation of the tangent line, so I'm going to use that point slope formula. The slope is 1/2. The x value we used was 5. When we put that x value into our function, we also got 5. So in point slope form, my equation is y minus 5 equals 1/2 x minus 5.